Hey everyone, we are looking at radical equations today. And remember when we talked about regular equations like x plus 2 is equal to 10, we talked about how you are able to subtract whatever you want. You are even able to add whatever you want. You can even divide whatever you want to everything, or both sides of the equation, as whatever you see fit. Some of it's helpful and some of it's not. In order to solve this equation, it's helpful to be able to subtract 2 from both sides of the equal sign, so you get x is equal to 8. We also talked about something like this. If your variable is locked inside of a squared binomial, it's possible to even, instead of adding, subtracting, multiplying, dividing, you can take the square root of both sides. X minus 5 is equal to, in this case, because you're taking the square root of both sides of an equation, plus or minus 8. Now we're going to talk about something else, which says that if a is equal to b, then it stands to reason that a squared is equal to b squared. And we can flip this around, that if a squared is equal to b squared, then a is equal to either b or a is equal to negative b. Same thing. And the second thing here was the square root property. But the first thing here, number 1, is just a squared property. So let's take a look at this equation right here, number 1. All right, number 1 says that the square root of x, and then outside of the radical, minus 8 is equal to negative 6. We can add 8 to both sides. This is just the first step of solving an equation, which is to isolate the radical. Negative 6 plus 8 is equal to 2. Now, because x is locked inside of a radical, right, before we could take the square root if it was locked inside of a squared binomial. But because this is locked inside of a radical, let's use this color. We can now take the square of both sides. We can square both sides. The square root of x raised to the second power is equal to x. And 2 to the second power is equal to 4, so we get our answer of x equals 4. Now, the one thing we have to do is we have to be able to check our answer and make sure that it works. So we're taking the number 4 and plugging it in for x. All right, again, notice that our equation is the same as our checking, just with a 4 plugged in instead of an x. And this, when you check, you're always evaluating. You are not solving an equation. This is not an equation to solve. This is just an evaluation. So the square root of 4 is equal to 2. Minus 8 is equal to negative 6. 2 minus 8 is equal to negative 6. And negative 6 is equal to negative 6, and it works out. And this is our answer. So back to here. To solve a radical equation, the first step in solving a radical equation will be to isolate the radical. Notice that the first thing here we did not square both sides first. The first thing we did was add 8 to both sides. That was the first thing that we did. So isolate the radical is the first step. Sometimes it will be done for you, sometimes it won't be. All right? After the radical is isolated, this is where you can square both sides now. And remember, you're squaring the entire side of both of each equation. Sorry, you're squaring each side, right? Not the individual terms. You're squaring the entire side, and I'll explain a little bit further what that means when it comes up. Step 3 is to solve the resulting equation, because after you square both sides, the result will be an equation to solve that you can solve through any means that we've talked about. And the very last step, which is an important step, is to check your answers, right? We're going to see equations that have multiple answers, and in that case, you do have to check all of them that come up. So number 1 is solved already. Let's look here at number 2. Let's move this up and give ourselves a little bit more space. Number 2 says the square root of 6x plus 37, and that's equal to 7. Notice that the radical is already isolated, right? It's already by itself. So now we can jump ahead to squaring both sides of this equation. Whenever you square this radical, the result is simply just whatever the radicand is, all right? In this case, 6x plus 37. The other side, 7 to the second power, this is equal to 49. So 6x plus 37 equals 49 should be an equation that is fairly simple to solve. You should be able to solve this without much problems, right? 49 minus 37 is equal to 12. Divide by 6 on both sides, and x is equal to 2. So let's check our answer, x equals 2. Again, we're taking this 6x plus 37, that's 6 times 2 plus 37, and this is all inside the radical, and this is equal to 7. So 12 plus 37 is equal to 7. 49 is inside the radical. Square root of 49 is equal to 7. And this answer now checks out, and x equals 2 is correct. Let's move up to number 3. 4x plus 17 is inside the radical. Plus 2 equals 3. This should be a 3. Let's write that a little bit cleaner. And we'll start off by isolating our radical, which is subtract 2 to both sides. 4x plus 17 is inside the radical. Equals 3 minus 2, which is equal to 1. So 4x plus 17, whoops, this is the result of squaring both sides. 4x plus 17, outside the radical now, 1 to the second power is equal to 1. And once again, a fairly simple linear equation. 1 minus 17 is equal to negative 16. Divide by 4 on both sides. X is equal to negative 4. Let's check that out. We got 4 times negative 4 plus 17. That's inside the radical. Plus 2 is equal to 3. So again, we're not subtracting 2 to both sides or anything like that, because this is strict evaluation, not problem equation solving. So negative 4 times 4 is negative 16. Add that to 17. Inside the square root is a 1. Square root of 1 is equal to 1. And then 1 plus 2 adds up to 3. And then, once again, our problem checks out. Moving on to the next problem. Again, isolate the radical. Square both sides. Solve the resulting equation. Check your answers. Isolate by subtracting 4. 6x minus 2 is equal to negative 4. Again, radical 6x minus 2. Square both sides. We get 6x minus 2 outside the radical. Negative 4 times negative 4 is equal to 16. That means 6x, after we add 2, is equal to 18. That means when we divide by 3, when we divide by 6, jumping ahead over there, x is equal to 3. This should be a 6. So let's check x equals 3 into our original equation. You're always checking back to your original equation, not anything afterwards, right? We want to make sure that this works into the equation that we were given, which is why we always have to go back to the original in order to do our check. 18 minus 2 inside the radical plus 4 is equal to 0. Square root of 16 plus 4 is equal to 0. Square root of 16 is equal to 4. So the left side adds up to 8. The right side has been 0 all along, so this does not work, which means x equals 3 is not a solution, and there is no solution to this equation. Now let's pause for a minute and take a look at what happened here. We solved this using all the steps and they were all proper, right? Isolate the radical, square both sides, solve the resulting equation, check our answer. Since the answer didn't check out, that means there is no solution. Now there is something called a principal square root, and that's what we're kind of looking at here, which is in our check, this portion here says the square root of 16. And that's equal to 4. This is the principal square root. That means that we're not considering that negative 4 times negative 4 is also equal to positive 16. Looking at both positive and negative square roots is the result of solving an equation, right? When you solve an equation, you are asking, someone is asking you, and you are answering that there are numbers here that work for this equation, where if you square it is equal to 16, and that result, that answer is 4, because 4 times 4, 4 squared is equal to 16. Well, negative 4 squared is also equal to 16. Negative 4 times negative 4 is also equal to positive 16. That's why the answer to this equation, x squared equals 16, has these two, 4 and negative 4, as answers. When you are taking the square root of a number, for instance, the square root of 100, that answer is only 10. I hope that clears up any confusion that comes up. So let's isolate the radical. So add 5a to both sides. We're working on number 5 right now. That's 5, 11a minus 30 inside the radical is equal to 5a. In order to isolate the radical, we can divide everything by 5. So we get 11a minus 30 inside the square root is equal to a. Square both sides because we've isolated already. 11a minus 30 is equal to a squared. And this is now a different type of equation, right? This is not a linear equation that we saw in the first 4 examples. This is a quadratic equation, and we know it's a quadratic equation because we have a variable, in this case, a to the second power. So remember our steps for solving a quadratic equation. Mainly the first step, which is set it equal to 0, right? Not factoring the first step, always set it equal to 0 first. So let's subtract 11a, add 30 to both sides. Because a squared is a positive value, we want to keep it positive. So a squared minus 11a plus 30 is equal to 0. And this factors a minus 6, a minus 5 is equal to 0. You can use the quadratic formula if you please. You can use completing the square if you want to also, but this is factorable, so factoring is going to be the most efficient way to go. Zero product rule, we get a equals 6, we get a equals 5, and this is an example where we got 2 answers, which means now we have to check 2 answers. A equals 6, we'll check first. That's going to be 5 radical. That's 11 times 6 minus 30. minus 5 times 6 is equal to 0. This is the first check. So we get 5 radical 66 minus 30 minus 30 equals 0. Is that right? Yes, it is. 5 and then radical 36 minus 30 equals 0. 5 times 6 minus 30 equals 0. 30 minus 30. And 0 equals 0. So A equals 6 works. A is equal to 5 was our other answer. So let's write this out. 5 radical 11 times 5 minus 30 minus 5 times 5. Running out of space over here, so let's move this just a little bit over. Equals 0. 5 radical 25. Oh, let's take this slower. 55 minus 30. Let's make sure our radical goes all the way out. Minus 25 equals 0. 5 radical 25 minus 25 equals 0. 5 times 5 minus 25 equals 0. 25 minus 25 equals 0. And there is our check. All right, both of these are going to work, which means this equation has 2 answers. All right, a couple more to do. 2 radical 3 minus w. We'll add w to both sides. Save some space over here. And we get 2 radical 3 minus w equals w. Now, in order to isolate the radical, we want to divide by 2. Radical 3 minus w, because these 2's cancel out, is equal to w over 2. If we square both sides, we're going to get 3 minus w is equal to w squared over 4. A fraction is going to come up here, and we don't like fractions. So let's go back in time a little bit, and let's take a look at this isolating the radical business. Because when I say isolate the radical, I'm talking about getting rid of this, that negative 5a. I'm talking about getting rid of this, that positive 4. This 2 that's in front of the radical doesn't really matter. Let's take a look. We're going to square both sides of this equation here as is. So what's going to happen there is that 3 minus w is going to come out of the radical like normal. The other side, w to the second power, comes out like normal. But since this 2 is outside the radical already, this is going to get squared to be 4. And this 3 minus w must be put in parentheses. So this is a way to avoid fractions. If isolating the radical by dividing is going to result in fractions, it doesn't really have to be done because this 2 is going to get squared. Right? So now we're going to distribute and get 12 minus 4w is equal to w squared. Once again, a quadratic equation that we are going to set equal to 0 and get w squared plus 4w is equal, minus 12 is equal to 0. All right, once again, a quadratic equation, and once again, factorable. What multiplies to negative 12 adds up to a positive 4. That's going to be a plus 6 and a minus 2. So w plus 6, w minus 2 is equal to 0. 0 product rule separates these factors, set equal to 0, and solving the equation, subtract 6 from both sides. Solving the other equation, add 2 to both sides. So w is equal to negative 6 is our first value to plug in, 2 radical 3 minus -6 minus -6 is equal to 0. Notice that we are plugging in a -6, which means that these negatives are still going to be there. We're just going to have 2 of them now. 3 minus -6 in this case. 2 radical 9 plus 6 is equal to 0. 2 times 3 plus 6 is equal to 0. 6 plus 6 is equal to 0, which is not true because 6 plus 6 adds up to 12. So W minus 6 is not an answer. Let's check the other one. W equals 2. Let's copy and paste over here a little bit because I am working on a fancy iPad. And we are taking the same equation, 2 radical 3 minus x, 3 minus w rather, and we're plugging in 2 for here and here where w occurred in the first place. So 2 radical 1 minus 2 is equal to 0. Square root of 1 is equal to 1. 2 times 1 is equal to 2. 2 minus 2 is equal to 0. We got an answer here. That turns out to be the only answer. W is equal to 2, and that's all. In order to get full credit, you must show both of these answers and check both of these answers. 2 more to do. This one should say equals x plus 6. Radicals are isolated, so let's square both sides. And here's a different new example coming up. X squared plus 8x plus 16. A very, very common mistake is to say that x plus 6 to the second power is equal to x squared plus 36. This is not correct. X squared, x plus 6 squared is equal to this. X plus 6 times x plus 6, and this is, after foiling, x squared plus 12x plus 36. Remember, when you FOIL this x plus 6, you're going to get x times x to get x squared. You're going to get x times 6 to get 6x, x times 6 to get another 6x, and that's going to add up to 12x. And then lastly, 6 times 6 is equal to 36. Set this equal to 0. This is a quadratic equation. Now it looks like this is factorable here. It looks like this is factorable here. But in fact, factoring is not going to help you because the first step in solving a quadratic equation is not factoring. Let's move the right side over to the left side. Let's subtract x squared minus 12x minus 36. And we're going to get negative 4x minus 20 is equal to 0. Now this is not a quadratic equation. This is a regular linear equation. Add 20 to both sides. Negative 4x is equal to 20. And that means x is equal to negative 5 after we divide by negative 4. Now when we want answer to check here, which is x equals negative 5. So that's going to be negative 5 squared plus 8 times negative 5 plus 16, this is inside the radical, remember, equals negative 5 plus 6. So inside the radical, that's 25 minus 40 plus 16 and equals 1. Add this up. 25 minus 40 is equal to negative 15 plus 16. That's equal to radical 1. And the square root of 1 is equal to 1. And this works, and this is our answer. One more to do, which is a similar problem to what we had before. Radical is isolated, square both sides. Once again, we are squaring each individual side, we're squaring each side of the equation, not the individual terms. So 2x squared minus 10x plus 9 is equal to the result of x minus 2 times x minus 2, which is going to be x squared minus 4x plus 4. Subtract x squared, add 4x, subtract 4. This is moving the right side to the left side. And we're going to get x squared minus 6x plus 5 is equal to 0. Once again, a quadratic equation that is factorable. X minus 3 and x minus, no, that's not right. X minus 5 times x minus 1, because negative 5 times negative 5 is equal to positive 5 and adds up to negative 6. So x minus 5 is equal to 0, x minus 1 is equal to 0, and we are getting our two answers here from the zero product rule. So checking x equals 5 means that we're going to have 2 times 5 squared minus 10 times 5 plus 9 inside the radical. And this is going to equal 5 minus 2. So 2 times 25 minus 50 plus 9 is inside the radical. On the other side of the equals, 5 minus 2 is equal to 3. Once again, notice that we are not adding anything to both sides. We are not squaring both sides or anything like that. That's to solve an equation. This is strict evaluation. And it works. 3 is equal to 3. X equals 5 is a valid answer. Let's check the other one, x equals 1. So 2 times 1 squared minus 10 times 1 plus 9 is equal to 1 minus 2. So 2 times 1 minus 10 plus 9 is inside the radical. That's 1 squared, that's 10, negative 10 times 1 equals negative 1. 2 minus 10 plus 9 is inside the radical. Negative 8. 2 minus 10 is negative 8. Negative 8 plus 9 is equal to 1, so radical 1. Square root of 1, again, this is where I'm talking about the principal square root. This is the square root of 1, which means it's equal to 1. And 1 and negative 1 are not the same. That means the left side and right side do not match. That means x equals 1 is not a valid answer, and x equals 5 is the only answer. If you have any questions, let me know over email, and I will see you